Jai Mahakal and welcome to Frontend System Design Yatra Season 1, and this is the introduction video. In this particular series, we will talk about how the browser works, what are network protocols, HTTP status codes, and from REST APIs, we start off with hands-on experience on each of the communication techniques as to how to connect a client and a server or connect two backend microservices together. We start with REST APIs, GraphQL, tRPC, gRPC, WebSockets, and polling techniques followed by WebHooks. Each of these techniques have hands-on experience, and you have the link of this particular Excalibur sheet, and along with you get the link of the GitHub repository where I have provided all the code which we will discuss in this particular series for GraphQL, gRPC, long polling REST, short polling tRPC, and WebSockets. All the hands-on experience code is available in this particular repository. So make sure you star it and fork it on your system. And please subscribe or follow me on GitHub as well. This is my profile. The aim for this particular video is around 500 likes. This video was initially planned as a bonus section on the Next.js Yatra series, but I have already announced before that no more content would be uploaded on Next.js Yatra series. Instead, all the bonus content would be uploaded now on YouTube free of cost for everyone. Whatever has been uploaded on Next.js Yatra is priced till that point only. You are not paying more than what is already provided on the course, so you are paying for what you are consuming. Moving forward, all the content is available on YouTube, and for each and every topic I have referenced many free articles which are present on the web, and the links for all the topics are already embedded in the description of this particular video. So you have the link to Excalibur, link to all the articles that are being referenced, or from where we have referenced the images are already linked to give credit to their work, and the link to the repository is also present. So you have all the resources which I have referenced to create this awesome series. So do give this video a like, subscribe to JS Cafe if you are new here, and share this video with with your community, with your college friends. Make this go viral so that I can bring more awesome series for you. So without wasting any time, let's get started. Let me introduce you to ZQ Cloud. ZQ Cloud is a global communication service provider which provides developer-friendly and powerful SDK and APIs to build many communication features on their app, such as video call, chat, video conferencing, and live stream, or a bunch of UI kits which helps you build faster and ship more with the UI kits. UI kits are built components that you can integrate in your application in shortest possible time instead of building them from the ground up. ZK Cloud has more than 20 UI kits, more than 50 components which are open source, cross-platform, easy communication, and ready to use. Let's talk about the live streaming app. Build an interactive live streaming and you can reach millions globally. You can create endless possible features with live stream SDK, such as live interactions, screen sharing, stream battles, real-time messaging, live streaming forwarding, and face beautification. There are a bunch of features such as social, live events, live shopping, live gaming streaming, live fitness, and live classes as well. The steps are really very easy. The first is you have to create an engine. Second, you have to create a room, start publishing the streams, and fourth, start subscribing to the streams. You can register at Zico, click 10,000 free minutes. The steps are really very simple. You just have to hit sign up, your name, last name. You can select your country and you can enter your email. Okay, you can get the verification code. You can also verify the stuffs. So you will get a email verification link. So you can check your mail. You can set up a very strong password. Once you land, you'll see a dialog box which will ask for some of your details. So you can provide the details, and maybe You can give this a little detail, your mobile number, and you can hit enter and you can go to the dashboard. As you can see that I have already received 10,000 free minutes, and this is my balance overview, and the overall dashboard is really very cool and really very easy. And you can see list of all your projects, stats, billing, and package. So overall, Zigo Cloud is really a one-stop solution for all video and chatting features for your projects. Let's come back to the video. Hi, welcome to the first module of this particular series, and in this module we are going to talk about components of browser. On the screen you are seeing a browser, so this square box represents a browser, and inside these we have various components: UI layer, browser engine, rendering engine, data component, network, JS interpreter, and UI backend. So we are going to talk in brief about some of the components, and followed by that we are going to talk in depth about the rendering engine. This is the most crucial part, and this is sometimes asked in interviews as well, so this is very important. And this series is is a part where we are going to talk about browsers first, so that you have an understanding as to how browser actually paints something onto the screen, or what are the various steps involved. Post that we are going to deal with all the communication techniques. So let's talk about the first component, which is the UI layer interface. So everything which you see on the browser, address bar, back, and the next button, home button, refresh, stop, bookmark option, these all comprise of the UI layer. So UI layer is just the front end of the browser, which is visible to naked eyes of the user. Next we have browser engine. Browser engine, think of it as a mediator between the UI layer and the rendering engine. We are going to talk about rendering engine in the second half of this particular module, but for now just understand that browser engine is responsible for keeping UI layer and rendering engine in sync, and we have it also interacts with the data layer as well. So what is a browser engine? It acts as a bridge between user interface and rendering engine and communicates with the data storage component. Next we have a really very simple component, which is the data. This data component is everything related to storage, be it cookies, cache, bookmarks, local storage, sessions. So be it persistent data, or be it partial temporary data. So everything related to storage is being handled by this component. Network layer, the name speaks for itself, is a component which makes HTTP request, WebSockets, and WebRTC connections, uses real-time transport protocol which uses UDP. Yeah, if you have seen the Google Meet clone video, we have leveraged WebRTC connections, where we are sending streams of video data between the users when they turn on their webcam. But yeah, so this was the network layer. Then we have a JS interpreter. JS interpreter, as the name speaks again, is a component which interprets and executes the JavaScript code. So it's really very easy. So whenever a server responds back you with JavaScript code, that JavaScript went to the JS interpreter. Then we have a UI backend. UI backend, think of it as a brain of the UI layer, which we discussed in the first step. It is used for drawing basic widgets like combo boxes and windows. So imagine that you have address bar, right? We have address bar, but what exactly is the functionality of this address bar is exactly what this UI backend component defines. So it is kind of a brain of the UI layer over here. So these were all the small components which we have talked in a brief, only just an overview. But the main part is the rendering engine. Before starting rendering engine, let's just quickly recap. UI layer, everything which is visible onto the screen to the naked eye of the user. Browsing engine acts as a mediator between rendering engine and the UI layer. Then we have a data layer for storing the data, network for HTTP, JS interpreter to interpret and execute code. UI backend is the brain of the UI layer interface. So this was the basic understanding of what are the various components of a browser. Next, we are now going to talk about the rendering engine. This is the heart of the browser, and this includes various steps. So how browser renders a page is what we are going to study now. All right, so we are now in the very interesting part of this particular module, how browser renders a page, rendering engine. So here is the flowchart of it, and we are going to talk about each block step by step in detail. So whenever you make a request to the server, so this is that request, and in return you get a response. This response is comprised of HTML, CSS, and JavaScript at the end. No matter what you write, you may write the front end in React or Vue.js or whatsoever, or even if you're writing it in PHP, okay, with some JavaScript, at the end, what you receive from the server is these three basic blocks: HTML, CSS, and JavaScript. And talking about CSS and JavaScript, the nature of these assets, okay, assets means files, so these assets is different. So CSS, as it is written over here, CSS is render blocking, JavaScript is parser blocking. Okay, so we are going to talk about what exactly is render blocking and parser blocking, because this is where candidates get confused as to when a CSS file loads, what exactly it blocks, when a JavaScript file loads, what exactly it blocks. Okay, so in this part we are seeing that this is the parsing step, this is a rendering step, and this is the part where a JavaScript or a CSS can pitch in and it can block you. So we have this CSS as render blocking, JavaScript as parser blocking, and both can trigger blockage at any point of time during the whole process. They come in effect as soon as they are found, when the code reaches the line. So imagine you got the code, inside it has HTML, CSS, and JavaScript, and the order can be anything. They might have inline CSS, they might be using external styles or inline styles, or in the JavaScript also they might be using inline JavaScript, or they are importing it, or is it CDN. Okay, there are n number of stuff or combination possible. Okay, so over here just try to understand that CSS is render blocking, JavaScript is parser blocking. Now once you get the response of HTML, CSS, and JavaScript, the first thing that happens is building of DOM, document object model. Okay, document object model. So this DOM is where we parse the HTML first. Okay, it is not like we are going to get HTML again and again, or HTML written something else. It comprises of what? This HTML body, head, meta link, p tag, span tag, and whatever is the level of nesting. Okay, that is what it is. So whenever you parse the HTML, you build this DOM tree. Okay, let me zoom this again a little. So this particular HTML, then inside this tree, okay, it is a DOM is a tree like structure. So we get a HTML, inside HTML we have head, then in the sibling of head we have body, inside head we might have meta tags, the link tags, then inside body we might have whatever content you want to write. So for example, I might have a p tag has a text, then we have a span tag, then again a text, then might body have a div tag, and then inside that there might be an image tag. So this is the DOM. So what it does, first thing the browser does is it builds the DOM, means that it parses the entire HTML. Once it parses the HTML, it makes it starts parsing the CSS. Okay, it starts parsing the CSS. So this is where we make the CSS object model. So what you mean by CSS is that once you have the DOM ready, now each item over here, each p tag, span tag, div tag, or image tag, they might be having certain styles, because as a front-end developer you style these components. Okay, so what a browser does is it identifies that body might have a font size of 16, the p tag might have a font size of 16, and font weight of bold. Why this is grayed out over here? because this is being inherited from the body. Okay, you may see that font size 16 is present on the body, it automatically gets inherited to all the child, okay, all the children over here. So that is why it is grayed out. Grayed out means that it got inherited. Now over here, these bold ones, the black ones, these are the styles that are coming from the CSS styles. Okay, these are not inherited, but they are directly attached to this particular element over here. So p, span and image, they might have certain styles. Okay, so once we attach certain styles to the DOM nodes, it becomes a CSS OM. But CSS OM is not the final tree which we have. Okay, CSS OM is not the final tree which we have. Okay, after this build DOM and CSS OM, these two guys are combined to form a final render tree. This is what a render tree looks like. So over here you can see that, let me keep it like this, I hope this is visible. So over here you can see that the render tree is this is what is actually rendered on the screen. You can notice that this head, meta, link, these were not present in the render tree. Why? Because these head, meta and link, they are not actually contributing in the rendering process. Okay, so what it does is, browser does is, it let go of unnecessary trees which are not required. Okay, so for example, these are not required, so they were let go of, and this HTML was also not contributing, so they let go of. But what exactly was contributing was this body and the styles. So this is what it calculate. So it took body, it took font size 16, and it starts superimposing the styles which are required. For example, I might add a font size 16, font size 20 pixel on this span tag, for example. Okay, for example, I have added this. You can see that now I have to decide key this span tag, whether it should be font size 16 or it should be font size 20. So this is what specificity is all about. So span tag would actually take 20 because this is directly assigned to the span tag, and this 16 was inherited. Okay, this is what is happening in render tree as well. And you can see that all the nodes, for example, this span tag is not present over here. Okay, why? Because it was empty. Okay, I think it was empty, but did they remove it or something like that? So body p, hello, span did had yeah, I think it was a mistake on the diagram. So span should also be present over here. I don't know why did they not. Oh, exactly, I understand. This was actually because of display none. Yeah, okay. So this style has a display none, which means that it is not going to be visible on the screen. So that is why, even though it has content, this span has content, web performance, but due to the stylings in the CSS OM, the display none property was applied, and in the final, now it is up to the final render tree to decide whether I have to include this span or not. Okay, that is what it is. So you can see the importance of render tree. Render tree is an optimized version of DOM and CSS OM combined, and it let go of all the unnecessary tree which are not required, and it also applies the styles based on a specificity. Okay, so we have div tag, it is verified. So we have div tag as well, we have image tag as well, then we have styles as well. So you can see that DOM and CSS OM, they got combined and they resulted in this render tree. Okay, this is render tree. And just for your information, the whole phase between parsing of HTML till parsing of CSS is called parsing step over here. Okay, and over here, if you remember, JavaScript is parser blocking. Okay, JavaScript is parser blocking, which means that if by any chance during this process, by executing your file line by line, if by any chance the browser encounters JavaScript file over here, it will stop the parsing in this step and it will execute the JavaScript first. Okay, that is why you will see that if you have heavy files, then the browser takes time to display things on the screen. It is because due to this step. Okay, the browser was trying to build the DOM, build the CSS DOM, and then move forward, but between that time it found what it had got JavaScript file. Oh no, I have to start executing it. So it starts executing the JavaScript file and it pauses the parsing then and there only. Okay, so this was the parsing, and this was the rendering step. And if you remember that CSS was render blocking, so this step over here of where we get the render tree and we start building the layouts. I have not told layouts yet, but this whole step including these two is rendering. Okay, now if in between this step you encounter any CSS, okay, any CSS overrides that come over here, then again it will pause the rendering and it will start the rendering again. Okay, because it will say, okay, oh no, I render tree decided that this p tag might have font size of 16 pixels. Okay, now it was about to build a layout of that p tag on the screen, but somehow from somewhere another style came in. Although it is very rare, not occasionally happens, but even though if it happens, it say, oh, all of the work I have done is gone wasted. Now again I have to build my CSS. Okay, now I have to say that, okay, instead of 16 pixels some other font style had come. Now this is what it is. Now I have done, I will again combine DOM and CSS and then I will make a render tree again. So this is where CSS is render blocking. Now once you get the render tree, you start building the wireframes of the page. Okay, what I mean by wireframes over here. So imagine that you are builder, you are going to build a house. Okay, now the customer says that, okay, show me what you are going to build. Okay, you will not go exactly and start putting the bricks over there, putting the rods and start building it and then show to the customer. Okay, you first make a blueprint of the house. Okay, you make a blueprint of the house and then you show that blueprint to, okay guys, this is what your house is going to be. Please tell me if there are any adjustment, if you want the room over here, if you want the dining to be over here or whatnot. Okay, this is what the wireframe is. That, okay, now I have all the elements which I want to show inside my render tree. Now using that render tree as my guide, I am going to build a layout. Okay, I am going to make some boxes. Okay, make some boxes as to, okay, this, for example, imagine these p and div tag are having certain heights and widths, some squares. For example, this p tag is 100 by 100, so it is going to be shown over here, something like this. And then in the next line, this div is going to take the rest of the space. Imagine. Okay, although the styles are not there, but imagine this is happening. So browser has to reserve some spaces. Focus what I am saying. Browser has to reserve some spaces for these guys. Okay, that is what is called wireframing. Okay, this p tag is reserved some space into this viewport. Then div tag is also reserved some space in forms of boxes, and I created a sort of a wireframe where eventually I will put some paint. Okay, so imagine there is a painter. Okay, so what they do, they first create sketches using pen, right? They create sketches using pen first. So they will build or imagine you were a kid, right? You have to make a house. Firstly you build that triangle, then you make a house, then mountains, and then you fill colors in those stencils. Okay, stencils is the correct word. So that is exactly what over here. During this wireframing, you create stencils on your canvas. Okay, that this is the div tag is going to take this much space, p tag is going to take this much space, and then you paint those stencils with your colors. Okay, so this is what the major step is. This is the part where you start seeing the items visually on the screen, and this is called paint step or paint tree, you can say. So earlier we got a build layout where build the wireframes and we filled those wireframes with some colors, which is called painting. Okay, and in the next step, imagine there is a website which opens up a modal when you click, or some ads, right? You might have heard Google ads. So whenever you land on a website, some very bad pop-ups comes on the screen, and then you have to close those buttons sort of things. So that is called layering. So you have already created a wireframe of a landscape for where your div tag and p tags are going to be. Then you paint them, but all of a sudden there's a modal on top of your on top of your canvas. So this is what composting is, that I have already created one layer, and due to some reasons there are some elements that are going to superimpose my canvas, is where composting or layering comes in. And this is where browser prepares or creates multiple layers. Okay, I might create 2 or 3 wireframes at a time. Okay, now don't get confused that I create only one wireframes. Okay, this is the part where I can create as a builder. You might have 3-4 properties, you might create 3-4 wireframes, and now you superimpose all those wireframes, and then you present the final offering to the user. This is what composting is, that you compose all the wireframes on top of each other according to the z-index property or whatever the developer has decided. Based on that configuration, you compose or layer those wireframes on top of each other. So this is the overall step of how a browser exactly renders a page, and this is the rendering engine. Okay, I hope you don't get confused whenever someone asks it. My agenda is that to deliver complex information in simple terms, so that you don't get confused and you answer it seamlessly. So the steps are really very simple. Quick recap: request, response, you get HTML, CSS, JavaScript. CSS is render blocking, JavaScript is parser blocking. Firstly, you build HTML, you parse the HTML. Okay, you called as building DOM. This is called a parsing step. Then you build CSS DOM, you parse the CSS, and if in between some JavaScript comes, it halts our parsing. Okay, and then you merge DOM, CSS DOM, you form a render tree. Render tree is optimized version of DOM and CSS DOM. It lets go of leaves which are not important. And when you finally execute or make a wireframe, this is called a rendering process. In this rendering process, you create stencils, and finally you paint those stencils. This is called the paint step. And finally, if there are multiple layers or modals or something, you perform a composting step or called layering. So in a high level, this was the module about components of browser and how exactly a rendering engine behaves. And the image which you see over here is obviously not created by me. I have used a third-party images. All the links which I have referenced to create this tutorial have been attached in the description. Do check them out. So for this diagram, I reference to this particular article by Muhammad Edring. What is DOM? How does HTML rendering happens in browser? And they have flawlessly explained everything which is required. And I think this was the image which I was referencing over here. You can check this fantastic article, and so are the other images as well. Okay, be it any image which you see in this article is not created by me. These are third-party images. Credits are given in the description, so do check out all these amazing documents. Okay, I'll see you guys on to the next module, which is network protocols. Moving on to the next module, which is network protocols, we are going to discuss 8 popular network protocols. Again, image is being taken up from ByteByteGo over here, and I think this is the website. It is already attached in the comments. You can reference it. Image is really very good. So again, talking about these protocols over here, I would be referencing them over here. So we have first the foundational protocol, which is HTTP, Hypertext Transfer Protocol. Instead, in this you have a client and a server, and you establish first a TCP connection, and then you send a request and receive a response. This is ideal for web browsing. And what exactly this TCP connection is, we are going to discuss over here. TCP stands for Transmission Control Protocol, and it is basically a sync and acknowledgement connections established between client and server first. So when you want to establish a connection, you send a sync request to the server, and in response the server responds back to sync plus acknowledge, giving that it has acknowledged your request, and then again you respond back with acknowledgement, given that you have acknowledged the response. So these three connections happen. Okay, and you can check this as well over here, TCP. So okay, we haven't talked about the back and forth connection, but what they are really telling is that in this TCP you can see that these lines, these are data packets, and data is not sent in a whole basic, but it is broken down is into smaller packets and it is transmitted over the network. This is your TCP. So if you go back to HTTP, where it says that you establish a TCP connection over here, which means that you first send and receive the sync and acknowledgement connections, and moving forward whatever connection is happening and whatever data exchange is happening is having in form of data packets. And the best part about this is that chance of losing a data packet is next to zero. Okay, and the data packets are safely transmitted from the server to the client. So HTTP and TCP we understood. Then we have HTTP3. In order to understand it, you need to understand the UDP connection. So all the devices which require very high internet bandwidth, given IoT, virtual reality. So in virtual reality you have to build the entire 3D area around you, and you need a lot of data to or bandwidth to actually send and receive data. So to do that we use a UDP connection. So in UDP connection what happens is there is a direct connection between client and the server, and the client and server, they transfer data to each other directly, and there are high chances that data may get lost in between because the connection is not a TCP one. So what happens is that if you are over a video call with someone and sometimes you see that there is a jank bit in the video, or sometimes the frame freezes and you lost a connection with someone for a couple of seconds, right? So this is what UDP although encourages high bandwidth data exchange between the client and the server, but again it does not guarantees that 100% of the packages would be delivered. Okay, so that is one drawback. If they switch to TCP again, they would ensure that all data packets reach the client, but the speed and the bandwidth would not be as much fast as of UDP. So over video conferencing we choose speed over the data packets, and over normal web browsing we prefer data packets. Imagine why this is done, because over the video conference call it is sometimes allowed. Okay, you may lose a connection for a second or two, but imagine you are giving an online examination on some platform and you use a UDP connection and data packets were not received to you, and partial data or partial pages were received. Imagine giving JEE advanced paper over UDP. Imagine data being not loaded completely on the portal. Then imagine what the worst case scenario it would be, right? So each connection has different use cases for itself. Then we have SMTP. Again, if you want to send mails over something, so there is a SMTP server. First the client sends a mail to SMTP server, then SMTP forwards it to the receivers, and so on. And then we have FTP, file transfer protocol. If you have used FileZilla before, if you are not aware of that, FileZilla is where we upload data or the projects itself, or maybe we deploy them onto some servers. So FTP comes there only. Then we have a WebSocket. WebSocket is a full duplex connection. First, it establishes a HTTP connection between the client and the server. It keeps that single connection open. We will also see that when we will implement the WebSocket. It keeps that HTTP connection open and full duplex communication happens. So over HTTP, the client can what is happen is it is a one-way communication. If the request is happening, either it is sending a data or it is receiving a data. In WebSocket, what happens is inside the single HTTP connection, you perform a duplex connection. You are sending the data, receiving data in real time. Okay, this is TCP. And yeah, about HTTP 3, again, this is what the most of the connections IoT and virtual reality use. They use UDP connection instead of TCP, so that the data transmission is fast and they can quickly load the application or run the application in high bandwidth network. So these were all the major network protocols. You can give a quick read of these basic protocols as well over here. Moving on to the next point, which is the HTTP status code. Really very simple. So whenever you make certain request and you get a response, so it has certain status code. It can be 1xx, 2xx, 3xx, 4xx, and 5xx. XX is not a standard. Okay, it is something like if we have heard of a 404. So 404. So 04 is replaced by XX over here, and it can be any number combination which is allowable. Okay, 404, 403, 401, 101, 100, 200, 202, 502, 500, and so on. So these numbers are categorized in 5 pillars over here. So 1xs are informational codes, which means that server has acknowledged and is processing your request. Where 2xs is the success code, which means that server has received a request, it understood and has processed the request, which means that it has either sent you a data, hopefully. Then 3xx are redirectional code. These are rarely used, I think, but let me read it out for you. The server received a request, but there is a redirect to somewhere else. In rare cases, some additional action other than the direct must be completed. So some, like, you made a request but it got redirected to some other service and so on. This is where 3xx comes into the picture. 4xx are client error codes. Okay, this is a part where 404 page not found or authorization 403 errors and so on. So whenever there is some client side error codes, okay, you want to tell client that something happened, some error happened on the client and it was not able to process, then it is 4xs. But if certain error happened on on server, it returns a 5xx. Okay, client made a valid request, but the server failed to complete the request. So this is what it is. And let me show you the link of the website as well. So yeah, this is the website, semrush.com, and they explain beautifully each and every concept. And this is the place from where I grabbed the image. Let me quickly find it. Yeah, this was it. You can read more about each type of request, like 400, 401, 2, 3, 4, and so on, so that it makes you a better developer and you know what these error codes mean. I won't be diving into each and every code because again it's not necessary for this tutorial, but it was just a heads up for you to understand when should we return 4xx, when should we return 5xx, and if you are getting 2xx or 3xx or 1xx, what does that means. So okay, so these were the link is already attached in the description. So these were all the theoretical topics we covered: components, rendering engine, network protocols, HTTP status code. Kind of boring lectures, I know, but yeah, these were crucial for forming the foundations of your system design. Next, we will now start working on the basic communication techniques. I'll see you guys in the next module, and we'll also start coding as well. So now we are getting started with communication techniques, and the first technique which we are going to discuss is the REST APIs. REST stands for representational state transfer, and let me read this out for you so that we can discuss on it. REST API or a REST web service is an API that follows the rules of REST specification. So there are certain rules which we have to follow, which are that the client application and the server application must be able to operate independently of each other. So there is no dependency between the client or the server. They are not linked to each other. So once a server is created, any client can connect to that server. Okay, and vice versa, like if you have a client that is accessing, then if the server is having the same configuration, you can connect to that server as well based on the REST protocols. Okay, and then we have each request from the client to server must contain all information needed in order to understand and process the request. Pretty straightforward that if you have a REST request, get, post, put, delete and patch, the request should be sufficient enough so that it can get processed easily, and the responses should be defined as cacheable and non-cacheable. It's optional. Okay, whether you want to cache the response or not, it's up to you. These articles which we discussed just now, these are being referenced from this particular article over here, hyperdesk.co. The links are already in description. If you want to read it out, you can go through this. And now we are going to do some hands-on over the REST is a kind of a concept, which is, if you do it practically, then only you will be able to understand. And if you expect me to explain this verbally, it's not that possible. Okay, so we are going to do hands-on over this REST architecture, and I'm pretty sure that 80 to 90% of you guys have already done or have a hands-on with the REST APIs already. Think of it as a quick summary or revision kind of stuff. So we are going to deal with how exactly we can create REST API in Express.js, and what are the various paradigms of get, post, put, delete and patch, and how we can eventually use client as postman to communicate. So that is what we are going to do. For this, I have already set up a repository, Frontend System Design Yatra, and inside it I have created a folder called networking, and inside we have a folder called REST. This is the place where we are going to write every code related to the REST API. Okay, I know that the summary is not expressive enough for someone to understand if they are looking at it at the first time. So we are going to go into the code and understand it step by step. Have patience, we are going to deal with it. If you have already done it before, you can completely skip this part and move on to the next module. Alright, so you can reference this article as well if you want to see how we can set up an Express server and Node. Since this is a system design course, not a Node.js course, I am assuming that you have some basic understanding of how to set up a basic Node.js application from scratch. If not, then I think you will see me doing it and you will learn. So we have a REST API over here. Okay, so we have a REST. So we'll cd into networking and REST. We will firstly initialize this as a npm package. I hope this is visible to you guys. Let me zoom this a little more. So I'll do npm init. Okay, then just hit enter. So we have this package.json created. We'll install two packages, which is Express and Nodemon. Okay, so now we have a package.json file present over here. Okay, and let us set up our server file. So new file, server.js. Okay, and we are going to initialize the start command, which would be something like nodemon server.js, and let us save this. Okay, now over here we have to define the module. So if you want to use import statements, you have to give it a type as module, otherwise that is fine. So since I do want to use it as a module, so I'll just say type module, save this, and now over here you can do import express from Express. So import statements will work, otherwise you have to use require. It is totally your choice. We will be switching between module and non-module files eventually in the further modules as well, but because I just wanted to let you know that this is what it means. So if you use type module, you can use import statement, otherwise it will throw error. Okay, so we have imported express. Now I'll initialize my app like this, express, and app.use would be express.json. Okay, and then I am going to define my port on which it is going to run. So port is 3000, and what we have is app.listen. So app.listen port, we have a callback function which gets executed, and I'll say console.log server up and running on port. Okay, let's save this. Now we are inside the rest folder. All we have to do is npm start, hit enter, and it is going to run our server. Okay, so this is the server running. Now let me grab the data once. So this is the data, these are the problems over here. So let me grab this and paste over here. We are not going to use database and all, otherwise the course would become lengthy. The agenda is pretty straightforward, that I want to let you know what is a REST, what are the basic functionalities of the REST API's architecture, and how does it works. So if we start introducing DB, then it's going to get fairly complex, and the length of the video is going to increase. That's not what I want. We have already discussed how we connect database and all in previous videos, Google Meet clone and other stuffs as well before. So that is not required right now. All right, moving forward, let us now start defining the problem. So we have a data called problems. Imagine this is coming from database, and this problem currently we have two problems on jscafe.dev. So imagine I am creating backend from my jscafe.dev. So this is a problems API. So if you're not aware, jscafe.dev, challenge yourself, and you'll get list of all the problems over here. So this is what exactly I'm trying to achieve over here. So these are the problems. We have ID, title, description. Now imagine that I have to fetch, I have to create a fetch API. I have to get all the data. So as per the as per the schema, we use get REST API, which is used for retrieving the data from a server. And this is what the endpoint would look like: https jscafe.dev/API/problems, method get, body none, query params optional if it is needed or not. Okay, so I am going to create endpoint called /API/problem. So how do we do this? It is fairly very simple. App.get, then your API/API/problems, and in the callback you get we get request, we get response. Okay, and since we are just returning the data, so I am just going to say response.json problems. Okay, I am just creating this API. Now let's head over to Postman, localhost 3000 /API/problems, and let me hit this, and you can see that in the response I got my data. Okay, this is the response which I got. So I got my data over here. Pretty straightforward. So this was the simple get API. Make sure that this is a RESTful architecture over here. Get, post, put, patch, delete, hidden options we can ignore, not needed, but these are all the major APIs which are going to cover. So I created localhost 3000 /API/problems get request, body, no body was passed, and we got our data. Awesome. Now the next goal is put. So we want to create a new problem on the resource. So how exactly do we do this? So I created what is the endpoint? So endpoint would be https/www.jscafe.dev/API/problems. We have a body, method type post, query params are optional. Okay, so we have to pass all data in the body. Okay, let's do this. App dot post slash API slash problems. Okay, notice that although the endpoint is same, okay, you're going to see that all the endpoints are slash API slash problems slash API slash problems slash API slash problems. Okay, so this is one of the major architecture or rule of the REST API architecture, that the endpoint remains the same, only the type of the request changes. Okay, and later on we can introduce IDs as well, which I'm going to talk later when we come on to the delete and put endpoints. So right now let us try to create a post request where I want to create a new problem for you all. So how do we do this? So I created a post, then request comma response. So API slash problems request comma response. Now we get the body. Okay, we will get the body using const body equals to request dot body. Okay, this is how we get the data. Now we have to introduce new problem. So I will do something like problems equals to this is an array. Okay, so this is an array dot 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 problems. We spread it out, and I am going to create new problem. So everything is present in the body. So I am going to insert the body over here like this, and then response dot JSON problems. Okay, save this. Let's come over here. This is post request. The endpoint is like this. Okay, we have the body, select raw JSON, and over here what I am going to do is, let me grab some data like this, and let us add quotes. Oops. Okay, ID would be 2, polyfill of promise dot not promise, let us do something like polyfill of array dot map. Okay, some description, and we can remove this comma, some description 1, and let's hit this. Okay, now you can see that we have 3 problems in the database, and if we go back to the get and send it again, we see the new one. Okay, so this is the post request. We were able to create new problem. Now what we are going to do now, next we are going to let us go back to the slide. We are going to do a put request. So inside put request, we completely update a specific resource. Okay, so this is what we are going to do. So we are going to create a put request, app.put, and let me give you a brief. So endpoint, this part is same, this much part is same. Then we introduce a new ID over here. Okay, this is new stuff. So because when we are going to update a new resource, we need to identify, we need to give the ID to that resource ki, acha, this is the problem ID I want to update, and this is the data. Okay, so this is what actually the update is over here. So let's create this endpoint. It is pretty interesting. So slash API slash problems and slash ID. Then we get request comma response. Firstly, we will extract the body. Body would be request dot body. Then const ID would be request dot params dot ID. So this is a variable over here. Okay, this is a variable. We get the ID from this, and then we are going to do problems equals to problems dot map, P for problem, and if P dot ID equals to ID. Okay, By not triple equals to, because here it is number, and here over here it is a string. Okay, either you convert this to number and then use triple equal to, or use double equals to. It's totally up to you. So if this is the case, then return id and body. Spread out the body like this. Okay, and else it is return p. Now we are going to return response.json problems. Okay, save this. Now we will do firstly get request, fetch all the problems. Okay, you see that old data was gone. Why it was gone? Because server restarted over here. Okay, I think you already know this basic stuff. Server got restarted, so all this data got refreshed, and a fresh server was created. That is why the data was gone. So I want to create a new problem. So I will do this again. I get a new problem. Now I want to update the problem. So I will do /API/problems/1. Body would be like this. In the body we don't pass the id, we pass the title. For example, it will become task scheduling problem, and we have some description like this. Okay, let us hit this. You can see that what is happening. So we want, yeah, so this was the id1. So id1 got updated, task scheduling problem, some description, and if we go back and do get again, you can see that we get task scheduling problems. So this way we completely updated all the data of the particular problem set. Okay, this way we have done 3 APIs. Now what is remaining? Delete. So we have JS protect /API/problems. We just give the id, no body, method type delete, and the query params are optional. This way we will able to delete one problem from the array. Okay, so it is very simple. Okay, very simple. I think I can just copy this, paste it over here. Instead of put, write delete. Okay, there is no body, we have the id, problems dot filter, and we can remove this. We can remove this also. I want to filter all the IDs. Okay, so if p dot id is not equals to id. Okay, this is what we are going to do. Let's save this and come over here, API/problems. So let me grab this like this. Okay, so I want to delete the first problem. So what we have currently, we have 0 and 1. Now if I do delete of id1, save this, we have only one problem remaining. Now if I do get again, we have one problem remaining. So this was simple delete API. Now what is remaining? We have remaining this patch one. Okay, patch is used when you want to partially update some resource. Okay, what I mean by that is, so this is similar to this thing put. In put we completely update the data, everything, and in patch we want to partially update the data. Okay, what I mean by partially is that you may either want to update title, you may either want to update the description, and so on. So this is what we are going to do. So let me grab this put wala API and put this over here and give this as patch. We got id, body, request, and what only change we have to do is, firstly we have to find our problem. So problem equals to problems dot find problem, p dot id equals to id. We got our problem, and instead of spreading the id, I spread all the properties. I spread all the properties of the problem, and then why is the app crashing? app.patch is, oh, spelling mistake. Okay, app dot, yeah. So coming back, so we got the request body, we got the ID which we want to update, we find the problem which we have to update, then we start iterating over the problems map, and if the IDs match, I spread out all the existing property and I update, I pass the new properties. So this will get overridden, and then I return this object and I return P if the ID is not matching. So this is very straightforward API. So let me grab this in the patch /problems, and for example, let us say I want to update the title of this problem using patch. So currently we have polyfill of promise.all as the title. So after patch it should become new problem. Okay, new problem. The ID remains the same, the description remains the same. What if I want to change the description? New description, save this. You can see title was the same but the description got updated. This is the patch API. So we have covered all the basic REST APIs. Okay, and I hope you are able to use Postman. If not, please install this, pretty basic stuff. You can download Postman. Let me show you Postman. So this is the Postman, you can download it, it is available for free. Okay, so coming back, so we have covered all the basic REST APIs of the JS Cafe problems. So what we are going to do is we are going to add all the changes, kill the server. Okay, so git commit -m REST API. Okay, and let's just sync these changes. So you can always come back and view this. Okay, you can view this GitHub repository and make your changes. Okay, you can always come back and make these changes, or you can fork this repository to view and understand all the codes. Okay, so this was the REST APIs. Next, what we are going to cover is we are going to cover GraphQL. Awesome. So I'll see you guys in the next module. So now we are going to talk about GraphQL. After covering REST APIs, the next module is GraphQL. GraphQL stands for Graph Query Language. As the name speaks for itself, it is a kind of a query language where you can write queries. Now, why exactly do we need it is that so if you see a REST API, okay, for example, this is your database, so you want to fetch the players information, the teams information, and the matches information for some sports. Okay, so you'll have 3 different APIs to fetch these data, so which means that you have to make 3 network calls, 3 HTTP calls on the browser, and then you have to club those data in order to render whatever you want to show. What happens with GraphQL is that instead of having separate endpoints for each type of data, we have a single endpoint that listens for all the GraphQL queries, and now it is up to you if you want to fetch players, teams, or matches based on your needs. Okay, so this is what it is. So if, let's say, if I just want to fetch the players, I will say, okay, just give me the players, and from the same endpoint I will get all the players data, and same is for teams and matches as well. And we can make any type of permutation and combination. For example, I want to fetch players and matches but not the teams, or teams and matches but not the players, and so on. So this way it is very flexible for us to fetch any kind of data based on our needs, that too from single API, and we just have to change the query. This is your gist of the GraphQL, and this is why it was created. So if you see the GraphQL architecture, and before that let me read it out, this phrase for you. GraphQL central feature is the ability to request and receive only specific data requested. You neither request more data or less data, you only request data which is required and nothing more. This makes it simple to scale your APIs along with your apps. So if you see over here, there are multiple input output apps present over here. This can be Android, iOS, web app, or living room application. We expose a single endpoint, GraphQL endpoint, where you pass your GraphQL query from the client. It reaches the GraphQL server, it fetches the data and sends the JSON payload back to the devices, and these clients can query based on whatever data they want. So this is what the flexibility of the GraphQL is. We are also going to implement one basic use case for jscafe.dev website, where let's say I'll talk about that once we start implementing it. But before doing that, let us quickly see what are the basic differences between GraphQL and the REST. By performance wise, it has been proven that GraphQL is faster than the REST, because in REST you have to make multiple network calls, but in GraphQL all of the data is fetched in a single request. Query complexity, yeah, so the query is quite complex. We will understand it as we write, but here we don't have such queries. In terms of popularity, GraphQL is still growing and REST is already very popular. Resources and community growing, this is large. A learning curve, yeah, you have to learn GraphQL and try to understand the complexity, but learning REST is easy, as we have already seen in the previous video. File uploading doesn't comes out of the box in GraphQL. You have to use separate libraries to achieve that. And in REST it is pretty much straightforward. Web caching, we have to again use some libraries, but in REST it is inbuilt. And recommended use case, like you use this in multiple microservices and mobile apps, where we have, like in this case you can see we have many mobile apps using a single endpoint. So in this case we can scale the application based on the needs. And over here when we have simple apps, resource driven application, given that you just have one website and one backend server, okay, that is all you have, then in that case REST becomes handy, because there is no use case apart from that. So these were the GraphQL versus REST showdown. And again, these assets and the information have been taken up from multiple websites. The first one is wallarm.com, where you can understand basics of GraphQL. You can check this out, the links are in description. And then a basic difference between GraphQL and REST, we already saw this difference over here. And I think yeah, this was a diagram which I used, and some of the which we saw above. So now I wanted to show you another link, which is Studio GraphQL, where we are going to explore how the queries exactly look like and how they behave. So open this link, this is present in the description, and click on Run in Explorer. Once you hit this, you'll land onto the GraphQL playground, and you can see we have some data present over here. Basically we have continents, and inside continents we have countries, and inside countries we have languages. So this is the scenario, and you can fetch continents, languages, okay, and countries like this. And if you hit this example query, you will get all the data over here. We can now, if I say I want to fetch the continent's name as well in the example query, I can, if I go above now, I get the name as well. And even I can fetch in any hierarchy I want. For example, in the continents, I want to fetch the list of all the countries. I want their code, I want their name, and each country has languages. So I want languages and I want the name. So if I run this query, you will see for in Africa we have these many countries, these are their names, and these are the languages spoken there. So this is the power of GraphQL, that by just changing these query like this, you can change the output drastically, and it is very scalable. Okay, you can now add and introduce more stuff like this, and this will play accordingly. So this is what something we are going to do. And For our use case, we are going to build a use case where for jscafe.dev website, we have users and we have certain problems. Okay, so in the problems we have a solvers skill. Let me zoom this out. So we have solvers. Okay, I mean somebody did solve that problem, right? So this is an array of the users who have solved the problems, and this is the users database. Okay, they have their id, and inside the problems sorry, inside this problems field we are telling that these users have solved these many problems, these are their ids. Okay, so we have js cafe and roadside coder present over here. So this is what we are going to do over here actually. So things are really good, really interesting. Okay, you're going to like it, and we are going to build this out right now. Now we are going to write the GraphQL queries. We are going to make the GraphQL server and write some queries on the clients to fetch the data. For that, I am referencing to this article, although I'll tweak the example to our use case where we have users and problems scenario over here. But if you wanna go in depth about how the queries work and what are the use cases and some other stuffs, just to have a quick glance, you can go through this particular article. The links are already in the description. So let's come back to the project and let's create a new folder, and I'll call this as GraphQL. Okay, and over here we are going to create two folders, one for the GraphQL server and another folder for the client. Okay, and so we can close this one. We can cd into networking, or there is one good scenario, we can right click and open this. So I am already over here in the GraphQL server. Now I will do npm init, make a npm package. We will create a backend server. So let's hit everything, enter, and then I will create one server.js file, and we can remove this old code. Okay, so we have package.json, we have server.js file. Now over here we are going to install two dependencies in the server, npm I. One is nodemon and another is Apollo server. Okay, so this is the Apollo server which we are going to use, and if you remember this explorer, this was also Apollo GraphQL. So majorly we use Apollo GraphQL to handle GraphQL queries and make server, but there are other packages as well you can explore. But for this tutorial we are going to understand it through the Apollo GraphQL. Once we have Express, yep, so we do have these two guys present. What happened exactly? One second. Why is Apollo not present? Oh, I think I found the issue. This is not the package file we are looking for. This is the file. Yep. So we have Apollo server, we have nodemon over here, then this is our server file. Now what we are going to do is we are going to import two of the important queries which we are going to use. And over here, as you can see in the package, I have not decided the type as module. So we have to use require instead of import. Anyways, if you write module, you can use import. If you're not, you have to use require. So let's not do module and use require. So what we are going to do is I'm going to import gql const gql equals to require from Apollo server, and we are also going to import Apollo server. Okay, these are the two things which we are going to utilize to create the server and write the GQL queries. I will tell you what the schema is and what the resolvers are, but for now let's understand this thing. Now I have to add some data. So let me grab users and problems over here. Okay, so we have got users and problems information. So let's quick have a glance at this. So users have user ID 0 and 1, and in problems we have solvers. 0 means that 2 sum was done by JS Cafe, and 3 sum was done by JS Cafe and Roadside Coder together, and 4 sum was done by Roadside Coder, and so on. Okay, and over here you see 0 and 1 means that JS Cafe has solved 2 sum, and it has also solved 3 sum, and Roadside Coder has solved 1 and 2, which means 3 sum and 4 sum. Okay, so this is what the data is looking like. So this is again a typical use case of the JS Cafe website, where I have to show which users have solved which problems and so on, or how many users have solved a particular problems, total number of count, or show the list of the users problem wise or user wise. So this is what we are going to do. Now over here I have to define the schema of the response that we are talking about. So we have users, we have problems, so we have to define schema of users and the problems, and then we have to define the schema of the API query which we are going to write. Okay, so to do that we do it something like this. So I call this as type def equals to, and we write GQL, the GQL which we imported, and inside this we write our schema. Okay, so the first schema which we are going to write is of the user schema. Okay, a single user schema. So we are going to do something like type, let me split the screen over here once and show the users. So this is a user. Okay, so type user like this, and over here we have a ID property. Okay, so we have a ID property, name and problems. So ID is a ID. Okay, this is a proper valid type in GQL. Okay, then we have a name. Name is what? Name is a string, so string string, followed by we have problems. Okay, problems is what? Problems is array of problems. Okay, these individual numbers, we will not say it is array of numbers like this, because this is a relational field over here. So this 0 is actually equal to this particular object over here, this particular problem. So this would be a array of problem. We have not defined the problem schema yet, so I will do something like type problem, then again inside problem we have ID, title and solvers. So I will do something like, yeah, so ID is ID, then we have title as a string, and we have solvers. Now you have to guess what this would be. This is array of numbers or what? This 0 is what? This is user, right? So this would be array of user. Okay, this is how we define the relation. Now this gives us the power to include solvers in the API request. So if I want to fetch a particular problem and say find me everyone who has solved 2 sum, then it will give you, okay, these are the solvers of that problem. Or find me how many problems JS Cafe has solved, so it will fetch that many problems. Okay, this is the powerful type which we have defined over here. Now this is just for resolving the data type. Okay, this is just for resolving the data type. This we have not resolved what type of API request I am allowing. Okay, so for example, I want to fetch a list of all the users, I want to fetch list of all the problems. So here there is a special type called query. Okay, type query. Okay, and let's say I want to allow users to fetch all the users. So my API endpoint would look something like users, and it will return array of user and there is another endpoint called problem. Okay, problems, which is going to return me endpoint, array of problems. Okay, this is what the query is. This is the final query that we will run. Okay, we are not going to run user or problem, but instead we are going to run the user's query, and I will also show you how this is going to happen. Okay, this how this is going to look like. We will see that in future. So we have, once we have defined the types, we have to give resolvers. So let me open the type over here on the left so that we can write the resolver. Now what is a resolver? Resolver is like when someone wants to fetch a user, what query exactly I have to run so that I get this particular type. When someone wants to find a problem, what query I have to run in order to find this particular problem. And when someone runs this query inside users or inside problems, what exactly command I have to run or which database call I have to make, what is the exact structure of the SQL which I have to write so that I am able to get this particular user array or this particular user array problems. Okay, the only resolver we'll need is for this problems and solvers. Okay, because ID and name it can automatically resolve, but since this problem and solvers, these are related fields, so GQL is unable to comprehend as to how exactly I have to generate this problem or how exactly I have to generate this solvers. Okay, which we will see in a moment. So I will write something like this: const resolvers equals to an object, and here firstly let us type to resolve this query. Okay, so I am going to write query. This is an object, and inside query we have users and problems. So we have users, this is a function, and we have problems. Okay, yes, these are the two resolvers for query, and we have another resolver for problems and solvers. So how we will write this as query? So we are going to write user and problems. Okay, and now we have problem, inside problems we have solvers. Okay, then we get solvers. We have created resolvers for each of our stuff, and we will write the queries, complex queries over here, and using this type definition and resolver, we have to create our Apollo server. So how do we create server? So we will do something like const server equals to new Apollo server, and here we pass type defs. Okay, this is the type defs. Okay, so this was a typo, this was type defs, and we have resolvers, so we pass the resolvers. Okay, once the server instance is created, I have to listen this server on some ports. For example, I will use port 4000, and then we will use then, and we also get the URL as well. So let me extract the URL, and we will do console.log GraphQL started on URL. Okay, this is the server. Now if I try to run this server, okay, npm start, let us see what is happening. Okay, so there was some syntax error on line 15. Okay, we have users, we have problems, this is fine. This also, okay, there was a dot, instead there should be a comma. Okay, now let us see if this is working. Okay, there is some error still. So it says unknown type problems. Did you mean problem? Yeah, there was a typo as well. Let us fix this. Now if I try to run, okay, now GraphQL server is running. there was a typo mistakes present. Now we have to define our resolvers queries. Okay, this is the place where you write your exact database calls. Okay, if you are using Prisma, you have to write your Prisma call. If you are writing raw SQL, this is the place where you have to write your raw SQLs. Okay, now I want to fetch all the users. Okay, I want to fetch all the users, so I just have to return the users data. Okay, return users. So if you see, this is the users that I have to return. Now it will automatically try to resolve. Acha, we are returning user, array of users. So if you see this resolver, it says array of user. So acha, ठीक है. So you want to return an array. Oh, this is user. What is this user? Okay, this is this type. So I need ID, I need name, and there is a problems array. Okay, what is this problems? This will start solving from over here. Okay, it will query this problem, which we will write in a moment. Okay, so problems is array of problems. It will going to start from this particular schema. Okay, this is how you think in terms of GraphQL. Now quickly tell me, what should I write for problems? It should be, yes, you are correct. This will be return problems. Now comes the fairly complex part, which is resolvers of the relation queries. Okay, so let's try to quickly see the mental model. Ki inside users we have the problems. So these 0 and 1 should be replaced by 2sum and 3sum somehow. Okay, got it. So I should have a resolver of the problem over here. Okay, what I mean by that is, if I want to populate the problems over here, so I would get the user information. Okay, now what is this? So for example, this problems field is present in the users data. Okay, this is a users array. There are many users. This is the first user, this is the second user. Okay, so this is that particular iteration. So remember in the array.map, okay, remember in array.map, in the callback function, you get each value one by one in the callback. Similar is the case over here. You will get each user in the callback in this function one by one, and now using that as a callback, you have to return which problem I have to solve. Okay, so I can do something like, I have the user information, this user is present over here. I have the problems information. Okay, now I want to see this particular user 0, has solved which problems. Okay, it has solved which problems. So we will do something like return problems dot filter problem, and over here, if the problem dot solver includes my user ID, which means that I have solved. Okay, so if I do something like problem dot solvers dot includes my user dot ID, that is it. Okay, it is complex. Okay, it is, I understand this is complex, so let us reiterate over what we did just now. So this is the users. Okay, this is the users data, inside which we have problems. Key users have solved which problems, those are over here. 0 and 1 means that the user has solved 2sum and 3sum. Okay, now if we want to populate this 0 and 1, which means that 0 should be replaced by this object, 1 should be replaced by this object, then when our final query happens, we have id 0 name JS Cafe. In the problems, we have id 0 2sum, id 1 3sum. Okay, these two data are present. This is what we have to do. So in the problems resolver, you get the user information. Okay, this is the we are already inside the user data, and in this callback function you get each individual entry of this array. Okay, this is what it is. This is this object and this object you will get each time inside this particular callback function. Okay, this is very similar to array.map. Okay, in array.map you get each individual array item one by one inside the callback. This is what is happening over here. So you will get user information one by one in this particular value user. Okay, this is what object is. And now we have to see ki I have the user, I will get the ID. Now I have to see using this ID which problems include my ID in the solvers field. Okay, this is what we have to do. So this is what exactly I have written. Problem.filters, I am iterating over each problems, and from that problem I am checking that if problem.solvers includes my user ID. Okay, for example we have 0, so 0 is over here, 0 is over here as well. So if this is true, 2sum and 3sum will be picked over from the problems and they will be returned. Now similarly has to be done for the solvers. Okay, now over here solvers 0 means that only JS Cafe has solved this problem. 0 and 1 means that JS Cafe and roadside coder have together done 3sum. Now to do this, what we have to do is we have to again perform the same step. So for the solvers you will get problem. Okay, you all will get this value. So if we are using problems inside, you are inside users, so you will get user over here. If you are doing for solvers, you are inside problem, so you will get problem over here. Okay, now I have to do return. So I have problem ID over here. Now I have to do similar stuff. Yeah, this is similar stuff. So I have to do users. It is user or users. Yeah, it is users dot filter user and user dot problems dot includes my problem dot id. Okay, this is what we have to do. This is very similar to this user this one problems one which we have just written. Okay, now let us save this. I hope there is no error. Okay, let us save this. Nodemon. Okay, we have not. Okay. We have to do Nodemon also, right? So we have not written a start script. So start Nodemon server.js. Save this and we do npm start. Okay, we have the server running using Nodemon. Okay, we will save this again and our changes are up and running. Now we have to write our client. Client is nothing but only a simple index.js file, index.html, simple HTML client. I fill the data with this and let's add a heading, GraphQL example. Okay, and we write a script. Now we have to write the client. Writing client is very easy. You just have to make a fetch call, and on the fetch call, since our backend server is running on HTTP 4000, oops, the server was killed by mistake. So fetch HTTP localhost 4000. The method is going to be post, and we have to give the headers. Okay, the headers are content type and some other stuff. Let me grab this quickly. Okay, Okay, yep. So this is the header, and the crucial part is the body now. Okay, so we will give the body and we will JSON stringify it, json.stringify, and over here we are going to give our query like this. This is going to be our query, and now here we are. So we are going to find all the problems. Okay, and inside problems, okay, this is very similar to what we have seen over here. Okay, this is what we are writing, this particular query. Okay, so I want to fetch the problems, I want the ID. Okay, I want the ID, I want the name. We have a name or what the data is? Yeah, so there's a title. So I want the title, and what we have solvers. Okay, so I want the solvers list as well, and in the solvers I want solvers is what? Solvers is user. This is the user. I want the ID and the name. I want the ID and I want the name. Let's save this. And if you have this extension with you, which is live server, okay, you can install this live server extension on your system, and make sure you have selected this index.html file, and you can click go live. Okay, this is going to run this, and if you go to console and if we refresh, so you see we got some data in the response. Okay, or maybe I should show it over here. So we made a GraphQL request. Okay, you can see this is the request happening, and this, I think this was the options call, and this is the actual call. Inside payload my query was passed. Okay, query problems like this. Okay, and this is the problems that I was talking about. So if you come back, this is the problems which I have written. Okay, problems, and this is the users. So problems, I am getting all the problems, ID, title, solvers. So if you go to response, we have got all the three problems, 2 sum, 3 sum, 4 sum, and 2 sum was done by JS Cafe, and 3 sum was done by JS Cafe and Roadside Coder, and 4 sum was done by Roadside Coder itself. We can change the output as well. For example, I wanted to now fetch the users. Okay, I wanted to fetch the users. Users have ID and name. Users have ID and name. Okay, and users have problems. So they have problems, and problems have ID and title. Okay, now we are doing it vice versa. Okay, now if you see, we get 2 users, JS Cafe and Roadside Coder, and we see all the problems done by JS Cafe individually and all the problems done by the Roadside Coder individually. So this is the power of the GraphQL, because now given the requirement may change anytime in the future on the client, but nothing is going to change on the server. Okay, only the client has to make the changes on the query, and they can fetch any data they want. So this was the GraphQL in a nutshell for you. I hope you understood, because we only had single endpoint and we only changed the queries, and that's it. So let us do the honors and kill the servers, and let's do git commit -m GraphQL. Okay, and let us push this on the GitHub, and let's come back. You can see we have GraphQL as well. Okay, you can always come back and see this. All right, so we have covered GraphQL. You can anyways come back and explore this, but this guy over here, he has explained it very well. The links are in comments. And now what is left after GraphQL? It is tRPC. Okay, so in the next module we are going to talk about tRPC. Moving on to the next module, which is tRPC, which stands for TypeScript Remote Procedure Call, and we have its brother called as gRPC, Google Remote Procedure Call. So we'll first cover tRPC and then move forward to gRPC. Before moving on, let us understand what means by remote procedure call. RPC only means to communicate between two systems. Likewise, we have been doing the same with the REST APIs before. We connected client and the server. Same, likewise, we did in GraphQL, where we connected client with the server, GraphQL server. And similar is tRPC, where we connect client and server. But with gRPC, what is happening is that it is used to connect multiple microservices together. That's a major difference between tRPC and gRPC. Although you can connect client and server using gRPC, but that is not what gRPC was made for. Although there was a way figured out to connect client and server, but it's usually used to connect two microservices together, which we'll see in the next module. But for now, let's focus on tRPC, which is something like REST, something like GraphQL, which means that it is used to connect client and server, but it leverages TypeScript heavily. Okay, so tRPC is not possible without TypeScript. So it is required that both client and server should use TypeScript at both end. And if you have seen cal.com, so cal.com uses tRPC behind the scenes. So if you go to GitHub, cal.com, okay, so they might have some place where they have written all their tRPC APIs. I forgot right now where exactly it is, but if we are contributing to open source, you know that cal.com is leveraging tRPC heavily, and the best framework which supports tRPC is Next.js. So let's go to tRPC's official website once, and you can see that they have a specific section to use Next.js and how to install it. Although we won't be using Next.js as an example for our understanding, but we'll use simple vanilla TypeScript and TypeScript node server to communicate and use it. Why to go into complex Next.js? I have alreedi taught Next.js. If you're not familiar with Next.js, so you can head on to learn.jscafe.dev and hit view courses, and you can land on to this particular Next.js course, and you can see what all we have covered. So we'll be building a Jira board, and it has various modules starting with low level design, project setup, environment setup and deployment, then setting up the database APIs, and followed by authentication, routes, and everything related to Next.js. So it is a great course if you wanna learn Next.js, and people are already enrolling it, and there is a special discount mentioned in the description. You can check it out over there. All right, so coming back to the topic, we were discussing tRPC. So over here you can see that what it is showing us that there is a server file, there is a client file, and if we have defined certain schema of the API on the server, and similar, if we make any errors on the client, we will be notified by the TypeScript. That is the whole agenda. And if there is a TypeScript error, your code will not get compiled. This is what the major role of tRPC is. And it says that move fast, break nothing. That is their tagline, which means that you can ship faster. The moment you make changes, you get automatically notified where exactly the client is breaking, and you can move faster with your development. This is the whole agenda. Okay. For example, they change the name from message. So over here, you have to change message to name. Okay. That is exactly what they are showing. This is what tRPC is, and we'll be leveraging tRPC to understand how we can sync vanilla TypeScript and a TypeScript Express server together using tRPC. I hope you understood it. So, all right. So we are going to configure the tRPC application, and first we are going to set up the server, a TypeScript Express server, and this is the article which we are going to reference, and link is already in the description. So it is creating a directory, and we perform a npm init in that folder which is created. So let's go ahead and create a new folder called as server, and I'll create a new file, sorry, a new folder called as client. So we have client and server, and let's move into the server. So I'll right click and open this in terminal. Let's hit npm init and hit enter with everything. Then we have to install these dependencies, which is express, TypeScript, TS node to compile the TypeScript, then the types of the respective packages. Let me grab this and paste it over here. Then meanwhile we have to define the tsconfig file, which contains all the configurations of the TypeScript. So I'll create a new file called this tsconfig.json, and I'm gonna place my configurations over here. All right. Yeah, because the file is not created yet. And then we are going to create a new file called as index.ts. Okay. And we are going to extract these guys over here, paste them. So I don't think we need a request response because we are going to deal with tRPC server, so we are not gonna need it. And we are gonna do app.listen port to initiate our server. So if I do, and I have to provide a start and the build scripts, let's go ahead and paste them over here. Okay, now if I hit npm start, okay, something is wrong. It is complaining that index.js is not found. Yeah, because it is not in src. Okay, we have fixed it. All right, now if I hit run npm start, okay, you can see the server is running. So we have the basic express server TypeScript present. Okay, and what we have to do is we have to integrate. Now this is all not relevant to us, we can ignore. What we have to do is we have to go to tRPC and go to backend usage. So we are creating a server, and you can see this is where they tell how to create tRPC routers and procedures. The main thing is that we have to, since we are making this in express, so we have various adapters to build the backend of tRPC. For example, you may want to do it standalone or with express or fastify, next.js, aws lambda, and edge runtimes as well. So since we are dealing with express, so this is how we are going to do it. So we are going to install tRPC server with npm. So npm I tRPC server, and let's import init tRPC. And what else? Yeah, this is the main thing, I believe so. Okay, let's go to define routers once. So we have got init tRPC, and I'm gonna grab these two guys as well. So we have the init tRPC.create. So we have the tRPC instance. Then we have created routers and procedures. I am gonna explain these routers and procedure later. Okay, as we create a router and integrate it. But for let us first of all focus on get the app running. And you can see that they have created a app router. Let me paste it over here, the app router. and they are exporting the app router as well. So this is all the boilerplate which we are doing. So we have done the basic installation of the Express TypeScript server, and on top of it we have imported the tRPC instance, and there is these are two weird instances which we are yet to discuss, which is router and public procedure. Using router, I created some methods which is returning a string. So as I have told that the only purpose where tRPC works is that client and server should reside in the same repository so that they can share the TypeScript methods. The client eventually will call the TypeScript method, for example greeting, which will help us fetch the data, and we can even batch them. So with this greeting function is going to be exposed on the client, and client can call this greeting function, and in return this is a public procedure query, and it is going to give us back the string. Okay, so this is the basic setup. Let's go back to Express, and from here I wanted to highlight this part, which is app.use tRPC. This is a critical part. So before app.listen, I have to do app.use tRPC, and from the adapters I am going to import the create middleware function. So this is the middleware, and so this is the function being imported, and this was the create middleware function. We passed our app router, and the create context is something I believe not required. We can ignore this. So we have the create express middleware. This is what the adapter does. It couples the tRPC with express so that whenever I hit this endpoint, my tRPC app routers could be invoked on the client. As simple as that. So we have a basic greetings application over here. So let's do npm start and see if everything is running. Yeah, the server is up and running. All we have to do is we have to set up the basic client, and we can use a Vite vanilla template. So Vite dev guide, what happened? Let's go back to Vite, get started, and this is the template which I was talking about. So the Vite supports lot of templates, and since we are going to deal with TypeScript, so vanilla TypeScript can be our go-to guy to create the client. We could have used React as well, React TypeScript, but again, why to complicate stuff when it could be achieved using vanilla, right? So let me grab this thing, and I believe I can delete this for now. Okay, and I can open this in integrated terminal, paste the command, and grab vanilla ts from the template, and let's call this as client. Okay, let's hit enter, and you can see that we have the basic client created for us already. So we can close this and open this in integrated terminal. We have to hit npm I before running this so that all the dependencies are pre-installed. Yeah, so this looks good, and let me open the main client file. We don't need any of this thing over here, and this is the index which is using src main.ts. So we are not gonna touch anything over here. Let it be Vite plus TypeScript, ignore that. The main point of focus is this main.ts file. Over here I am going to create the tRPC client, and tRPC client is being created like this. So we have to import the app router. Okay, let me take you through one by one. So we have to install tRPC server and tRPC client. Once this is done, we are going to import the app router from the server. Okay, and this is the file for the basic setup. So let's head over and grab these guys and paste it. Meanwhile these are getting installed, let me import my app router. Since this is not exactly the path of the app router, we have already exported app router over here. App router contains all the definitions of all type of invocations that client is allowed, be it greeting or updating data. So we can do something like // head over to server, and from the index I can import my app router. Once the app router is being defined, I have to import these guys, tRPC client. So let's paste it, and let me grab this piece of code as well. This is the tRPC client instance, and I can get rid of auth cookie, not required. We don't need headers. And this is the URL where we are running our tRPC. So localhost 3000, is it so? Is the server running? Yeah, it is localhost 3000, and /tRPC is our route where we have put the adapter. So this looks good. This is the app router. This is the client. All right. And what else we have to do is, now I can create a async function. Okay, and I can call this main function over here, and I can do something like client dot see. Now automatically I got greeting as a suggestion stating that client, these are all the invocations which you are allowed. So we are also going to do implementation of the problems API, where we fetch all the problems and update the problem. Okay, these are the two features which we are going to implement. So right now I'm going to show you what this means. So client dot greeting dot query, and I can call this like this. So this is dot query, and let us see what happens on the server, on the client. So we are in the client, and let's do npm run dev. It is running on localhost 5173. So let me open this, head inspect, and it says that it has been blocked due to CORS. It was trying to make a greeting request. It was trying to fetch, but it automatically got blocked due to CORS. We can fix this anyways. So I can do something like npm I CORS. Okay, then we can import CORS from CORS. Okay, and where is app.use? Yep, here it is, app.use CORS. Let us run this again. Okay, it might be complaining about types, so we have to do something like npm I /types /CORS, and this is now going to compile. Okay, and let's refresh. You can see that okay, a WebSocket call was being made. We didn't initiated that. Let's come back to the greetings, and you can see that this one, I got hello tRPC v10 as a API response. And if I try to call these multiple times, you can see that these requests were batched together. That is what this HTTP batching refers to. So we batch the request, and in response I got all of my data. All right, now let's move towards the problems API, which we have been discussing so far. What I'll do is I'll create a dummy problems array of data. We have ID, title, description, and let us say that I introduce a new. Let's create a new one, obviously. So I create a new one called get all problems, and this would be something like public procedure dot query, and as simple as that I am gonna return the problems. And we create another route, which is, let me paste it over here. We create another route which is update problems, which is again a public procedure where we get some input value and we validate that if this input is an object or not. If this is not an object, we throw a new error. If it is of type object, we return the value. It gets passed on to the mutation. Mutation is something, a procedure where we want to update something. Okay, so we use mutation to update, query to fetch something. So this, since we are going to update the problems, so we are using mutation, and in the callback we get a async function and we get all the options. We fetch our data using options.input, and this can be of type problem, which we have not created yet. So I can do something like type problem. Okay, and this is complaining because yeah, ID and other stuffs are not defined. So I'd say ID would be a number, title would be a string, and description is also going to be a string. Okay, so we have defined the problems. Yeah, there was some typo issue. These are small and have to put semicolons. All right, the type issue is resolved. So we get the data over here as options.input. And again, this is the same logic which we have done in the REST APIs key. We iterate over the map of the problems, and if the ID matches, we update the particular object. Otherwise, we return the object as it is. This was the basic mutation. And yeah, it is equal to is expected. This is fixed. And we can rerun our server again. And the server has compiled successfully. And coming back to the point, now if I do something like that is a greeting that is understood client dot, I can see 3 more options present, which is get all problems dot query. So that is one thing. Now if I head over to greetings and get all problems, so I get the greetings, and in the response I get all my problems as well, which is really very nice. And if I wanna update my updates any of the problem, I have to do something like client dot update problems dot mutate, and I pass on my data. Let's save this and refresh. You can see that a update call was made. Okay, and we didn't got anything in response. But if you check the get all problems data, you can see that the new problem was already present. So this is what we have successfully updated our problems array. So this was the tRPC under the hood for you guys. And make sure that the client and server, they reside in the same repository, so that they are able to share the app router between each other. This sharing is what makes tRPC possible. If backend and frontend are present somewhere else, then it would get really difficult. Or if you do, you can export a tRPC as a common package between client and server, but again that is difficult to maintain, right? So this is the basics of tRPC for you. I hope you understood it. And we are going to cover tRPC versus gRPC once we finish gRPC in the next module. So yeah, that was all. I'll see you guys in the next one. All right. So in this particular module, we are going to talk about the hot topic, which is gRPC, which stands for Google Remote Procedure Call. It has been developed by Google and they heavily use this gRPC. So that's why this is called Google Remote Procedure Call. And what exactly is the main purpose? The main purpose is to connect two microservices together. What I mean by that is, imagine you have a user service which provides information about the users. Okay, maybe what type of user is, or whether he has purchased some product or not. Imagine the case of Amazon might have to share this user base with the main Amazon e-commerce, and might also they have to share with the Prime Video as well. Then they have also have to share with this Amazon Alexa, right? And so on. So you can see that there is a single service which is communicating to different service, which is Amazon e-commerce, then Prime Video and Alexa and so on. So wouldn't it be the best case where I can solely create one microservice and allow it to communicate with the others? This is where the gRPC comes in. What they will do is they will put down the users, all the procedures, all the behaviors of the user, all the data that is required of the user under a gRPC service, and now all the other backend services will eventually call this gRPC microservice to fetch the user data. Okay, so this is what the main goal is, and this is language agnostic, which means that you can write gRPC in any language you want, so it is very flexible to use. And under the hood, it uses protocol buffers to transmit the data. So protocol buffer, you can go through the definition. It doesn't really helps you understanding what protobuf is, but just understand that this protobuf is a .proto file which defines the schema that is going to be sent or transmitted between the gRPC and the other service. Okay, so proto is the contract of the data that is going to be transferred from gRPC server to the gRPC client. So remember our use case. So the Amazon user microservice would be our gRPC server, and our Amazon e-commerce, Prime Video, Alexa, they are all the client. Okay, whatever their backend is called gRPC client. So don't get confused that if gRPC client means just a web service, just a web browser. Here client can be a backend microservice as well. So what happens is, this is the communication chart. This is how the communication happen. So you have a client makes a request, raw request, and there's a structured proto request. So we will understand this in a moment when we will create one client and server, and we will make them communicate. So using protobuf, they structure the data, they serialize it, and using HTTP2, we have already discussed in the previous modules. Using HTTP2, they transmit the data, and vice versa is this call that this is how gRPC sends it. So it creates a raw response data, it structures it using protobuf, then it serializes it, and then it sends out. Okay, so this is what a RPC call looks like. And I know that it might be kind of confusing because you might have never communicated two microservices together. You have always done either communicating a React application to a Node Express, or Angular application to Node Express, or you might be using Django or Flask as at the backend. So this is what the standard communication you might have done. But with gRPC, what is happening is we are playing at the backend level. Okay, this is there is no client over here. Right now we are now dealing with backend. Two backend services are communicating with each other. Okay, this is what gRPC is, and this plays a very vital role in system design interviews, because the moment you create multiple microservices, then the interviewer might ask that what is the way in which we can communicate these microservices together. In that moment you have to speak out that you are going to connect them via gRPC. Okay, so that is it, and we will do a hands-on as to how to create it and what are the things. And once that is done, we will do a one-on-one comparison between tRPC and gRPC. All right, so enough talking. This is the article about protobuf. You can check the comments, and if you want to read about protobuf in detail, you can read. And this is the article which I am going to follow to create a gRPC server in Node.js. We are not exactly going to copy it as it is. We are going to maintain our own example where we will fetch again, we will fetch list of all the problems for jscafe.dev, and we will update a specific problem. And by the way, I have just updated the landing page of the jscafe.dev website. You can do check it out. I created this yesterday only, as I'm recording today. So this is made using Eternity UI. Manupaji, you are rocking. Yeah, so this is looking pretty well. Anyways, coming back to the topic. Yep, so let's go back to the code. I hope you guys are able to see this now. So we are in networking. We are going to create a new folder, and I'll call this as gRPC. I'll create two files. One is client.js. Don't confuse it with React. Okay, this is going to be a Express server, and we are going to create one server.js file. This is going to be our gRPC server. Let us close other files. Okay, so let's go into gRPC npm init. All right, so we have a server client, a package.json. Now what we have to do is, all right, so we have to install some packages. So npm I express nodemon and the gRPC.js. Let me grab those files names. Yes, gRPC.js and gRPC protoloader. Okay, these are the two gRPC packages that we are going to utilize. Okay. All right, and as we have discussed before, there is going to be a protobuf file, which is nothing but just a .proto file. Okay, so we are going to create a proto file. This is going to be the contract of the data that is going to be exchanged. So new file, the problems.proto. Okay, now this proto syntax is something a little hard to understand at the first place. Why? Because you might have not written this before. So the syntax is something like you have to write syntax equals to then proto 3. This is all just boilerplate, so you don't have to worry about it. Okay, so this defines that which proto version you are using, then followed by your schema. So if you remember TypeScript, in TypeScript we create interface. So in proto we create message problem. So since we are going to fetch all the problems and update all the problems, so we have to let the system know what is the structure of the problem is. So the ID would be a string. Okay, we have a ID, and we number each property with numerical value. We start with 1, and we have a title, string title. We call this 2, and we have a description. This is what a problem would look like. Then we have to create one service. This is the service using which we are going to call our APIs. So we will say that I am creating one service. I will call this as problem service. And inside this problem service, I would have a RPC, remote procedure call, happening. And the first API which I want to create is to fetch all the problems. So I have to name this RPC procedure, and I'll call this as, let's say, get all problems. What are the parameters it is going to accept? Nothing. So we will say empty. And what it is going to return? It is going to return array of problems. Okay, we don't do something like problem arrays. Okay, this is exactly not TypeScript. So to do this, we do something like, I again create one message. I call this problem list, and in problem list I have array. So arrays are represented with repeated keyword. I have repeated problem. Okay, let me do this like this. So repeated problem, okay, which means that array of problems. Okay, and what is a placeholder or the variable, or variable that is going to hold the array? We will call this problem. You can call this list data, or you can just call it data, whatsoever, it's totally up to you. I will call this as problem. Okay, and problem list, or maybe we can call this problems, totally up to ourselves. And we are, since we have to number this, we number this as 1. And we protobuf also doesn't knows what empty is. So I'll create one message empty and just leave it blank. So okay, this is what empty should look like. Now we want to update our problems. Like, I supply the complete information, and let's say I just pass title and I pass the ID. So the problem matching that ID should be updated, and its title should be changed. So I'll call this as updated problems. Yeah, update problem. So what exactly this is going to take? This is going to take an object like problem, complete problem. So we have already defined what a problem should look like. So I will pass my problem over here, and in return, oh, there was one more thing. So we created this problem list, but I did not utilize it. So get all problems will accept empty, will accept nothing, but in return it would return us the problem list. Okay, this is what I was talking about. And update problem would return us the updated problem. That is as simple as that. Okay, so we have defined our schema. So let's move this at the start, and it's time for us to write the gRPC server using this contract. So first of all, we will initialize the gRPC variable or gRPC instance, and using require, I'm gonna say gRPC JS. Okay, and we define the protopath. Protopath is going to be the string dot slash problems dot proto. This is where our proto file is. Okay, then we have a proto loader. So we will initialize the proto loader, and let me bring this bottom. And there is one generic thing, which is this part. Let me grab this and paste it. These are just a boilerplate options, like, do we accept enums, do we want to accept keep case and long strings and so on. Okay, this is just basic options. You can ignore this. This is part of boilerplate which we have to keep. Okay, then coming on to the main thing is that we have to import the package definition. Package definition is protoloader dot load sync, and I pass my proto path and options. So this would give me all the definition. Let me fix the typo. Package definition. We loaded the proto using proto loader load sync. This is again the boilerplate. Once we have the package definitions, we have to extract the protos. We do it something like problems proto equals to gRPC instance dot load package definition, and we pass the package definition. Okay, this is the basic boilerplate. Now we create the server. Note that we are not using Express, okay, because Express would become our client, and to create a gRPC server we have dedicated ways. So for and this is completely language agnostic, since we are doing this doing everything of system design in JavaScript. That is why I decided to do gRPC server in Node in JavaScript only. You can on your own create this in maybe in Python, Java, Golang, whatsoever. So new gRPC dot server, and S is going to be capital. So we have the instance. Then let me grab the problems. Okay. So these are the problems that we are going to use the dummy data. Obviously, this is just mock data. When you are working with real projects, you are going to fetch them from actual database. So we have ID, title, description. Make sure ID is string. Okay, because in proto we have already told that ID, title, and description all are strings. Okay, so make sure these are strings. Now moving on, there's a lot of boilerplate, definitely. Okay, so this is like doing old Redux, a lot of boilerplate just to achieve simple stuff. But yeah, this is how the Google has created it, so we have to follow it. So then we have to add the service. So we did created problem service over here, so we have to add that service, and this is going to come from problems proto dot problem service. Let me grab this dot service. Okay, and then in the options we define our methods. All right, so these are the methods that we have created in the service, which is get all problems and update problem. So I have get all problems, and we get up our callback function over here. This is going to be a function. Second is our update problem. So update problem, we have call and callback. I'll tell you what these underscore and callbacks are, but right now let's focus on initiating the server. Then this is the place where I'm going to make database calls to tweak or modify our data. Okay, which we will write in a moment, but let me finish the boilerplate first so that then we can focus on the logic. Then we have server dot bind async, and I pass my local host 50051. This is the port, and then we pass gRPC dot server credentials dot create insecure. So this is going to allow non HTTPS calls, which is insecure connection, and I get error and port over here as callbacks. Then we do console.log gRPC is up and running, and we do server.start. it says server order start is not required, but anyways we are going to call this. So this is the basic boilerplate. What we do, we imported protoloader gRPC, we created package definition, and we fetched the problems, exact problems proto. Using this proto, we extracted the service and we defined all the methods in which we are going to make the call, and this is just boilerplate code to start the server. Now this is the why do we write underscore? So whenever there is a parameter which you are not going to utilize, you name it as underscore. Okay, if you are going to utilize, you call this as any whatever name you want. All right, so when we say I should return, I should get all the problems, so this is the callback function which is responsible for sending out your data. Okay, the first parameter is null, and let's come back. So I said that get all problems should return the problem list, which is this. Okay, this is the problems. So this is going to return the list of problems. So I will do problems and problems. Okay, this is the data which we are returning it. And if you come back to the part where we have to update the problem, so firstly I want to get the ID of the problem. So const ID equals to call dot request dot id, you get the id, and followed by that you update the problems equals to problems dot map p if id is equals to p dot id, then return everything of p and everything of call dot request. So it is like doing request dot body. That is similar is what call dot request is. Request dot body from express. Okay. Okay, mic check. And if this is not a match, we return the problem as it is. Then we find the updated problem, because as per the contract, I don't want to return the list, I want to return the updated problem. Yeah, that is what it is. So updated problem equals to problems dot find p dot id is equals to id, and in callback I pass null and extract updated problem. All right, so we have created the basic gRPC server. It's time for us to run this. So nodemon server.js, and nodemon is not present. Yeah, totally understood why. So instead of doing nodemon, can we do node server.js, and it started failing. So we have some issues. Illegal token messages are not here. Then maybe this is complaining on these lines. So where exactly is the issue? Oh, okay, maybe I think I missed a semicolon over here. Okay, still complaints. So it says illegal token return. Okay, where returns expected. Oh, okay, so there is one more typo, returns. Okay, all right, now this is gRPC is up and running. So we have the gRPC running. There were some typos that got resolved, and now we are going to do the obvious. The obvious is to create an express server. I want you guys to pause this video and create this on your own, because we have been doing it for quite a while. let me also grab the stuffs that we would need for the gRPC. So again, this client has two parts. One is the gRPC client and the Node.js server itself. So I'm gonna extract the gRPC first, which would be require gRPC.js and obviously the proto loader. So again, we would require these two guys. And we also have the proto path. So we would need the proto path. Then const express equals to require express, and const app equals to express. What else did we? JSON app dot use express dot JSON and app dot listen some port 3000 console dot log. Client is running, and now over here I'll introduce the endpoints that are going to perform these actions. So the first one would be app dot get slash get all problems. Okay, all right. Now yips. So we are going to firstly utilize and create the client. This is, we are again going to utilize the options, and what else, package definition. So this is going to be the same. Okay, and once this is done, we are going to extract our service using problem service equals to gRPC dot load package definition, pass my package definition, and I call my problem service. Okay, and I create my client instance. First client equals to new problem service, and my service, my gRPC service is as stated on localhost. So this would be localhost 50,051, and this has to be insecure. So gRPC dot credentials dot create insecure. All right, now we are done with the client, and now for fetching all the problems, I have to do over here. This is the thing. Now there are three systems involved in this complex structure, which is, one is the gRPC server that is transcommunicating problems information, and we have a backend service, dedicated backend service to get all these problems, which intentionally is going to fetch from this client object, which is nothing but which is going to call the gRPC server, and this express server is going to be eventually called from a front end client, be it a React, vanilla, or maybe we can use Postman just for the purpose right now. Understood? So I would do something like client dot, what was the name? It was get all problems. So client dot get all problem. This is the magical stuff happening. So client dot get all problems. This is the place where you can pass on the data, and this is the place. The second parameter is error, comma data, or let's call this problems. This is the place where you get the problems, and if error, throw error. If there is an error, just throw it out. Otherwise, response dot so request dot response dot JSON problems. All right, this is the first service, and the next service is app dot post slash update problem, and you pass the ID request comma response. Help me out, write this one. Okay, help me out, write this one. So const id equals to request dot params dot id, const body equals to request dot body, then client dot update problem. See, the only painful task was setting up the gRPC server. Once that is done, using the APIs from the gRPC is piece of cake. We will do client dot update problem, and we will pass the object. I will pass the ID, and I'm going to extract the body, and then am I doing it correct? Yeah, and then I get error, then updated problem, and it says if let me grab this quickly. Okay, so if error throw error, otherwise respond me back with the updated problem. Awesome, this looks cool. Let me create another server in cd networking gRPC and node client.js. So client is up and running. Let us start testing it on Postman. So what do we have? Localhost 3000, get all problems. Let us hit this request and boom, we got all our data. So what happened? Can you summarize in your mind what exactly is happening? So imagine this Postman is a React application. It made one API call to localhost 3000. Localhost 3000 was our Node Express server, this client.js file. It came here and it said app.get this URL, and eventually it called the gRPC microservice, gRPC client server dot get all problems, and we got the data over here and I returned it. Okay, so this is the power of gRPC. Now imagine you can create, you have one service, this service, you can create n number of services in n number of languages without any restriction, and you can interchangeably transfer data with each service. So this gRPC is very much powerful, very much powerful. All right, so let's do with update problem. It had to be a patch request. Okay, so please be mindful. And in the body, this is new title, this is new description. I send it and it says cannot post localhost. Once a second. There is some problem. Yes. Can you figure out what was the problem? Slash was missing. Now you can see we get ID description, and if I remove description, now it says something that yeah, this was missing. Yeah, so you can see that description went empty. Can you imagine why this is happening? This is what I wanted to elaborate on. So if I do console of call dot request on the gRPC server. Okay. This is my gRPC server. Let us run this again. Okay. Now, firstly, I will fetch all the problems. Now I will update it and see what will coming. ID, title, description is by default empty. Okay. Description became by default empty. That is because contract was set by protobuf कि भाई I want problem, which means I want ID, title and description to be present. If you are not sending it from your side, I will attach this property and make this empty. So this is one thing which you have to be careful while using gRPC as a microservice. Understood? So this was the critical portion which we have to deal, and you can see the title was updated, and if you fetch again the problems, it is new title and description. So this was gRPC in the nutshell. Let's come back and do a quick one-on-one difference between tRPC. tRPC is it focuses on connecting client and server, as we have discussed before also. It connects a TypeScript client to a TypeScript server, and gRPC focuses on connecting two microservices. tRPC uses TypeScript. gRPC, it can be any language, and tRPC uses TypeScript functions between client and server, that we have already seen, that we call specific functions between client and server. Here gRPC uses protocol buffers as contract. We already saw that description wala issue, that even we don't pass description, it was coming. Okay, then it uses TypeScript safety for APIs. It uses binary serialization. Again, too technical term, not required. It confuses you a lot. And it this can be used by TypeScript only. It is language agnostic. Same point, covered into different languages. And tRPC is simple and flexible. tRPC gives support, definition, automatic code generation, blah blah blah. They have written anything. So these were the major differences between tRPC and gRPC. And there's one more thing which we always do is push our changes. Commit -m gRPC. Okay, and if we go back to the, where is, yes, this was updated just now, gRPC. Yeah, so all the code is present. You can try it out as well. So we are very close to the end of this module. The only two steps are remaining are polling techniques and WebSockets. So I'll see you guys in the next module. In this module, we are going to talk about the polling techniques, which are short polling and long polling. What exactly polling is, that the client seeks for an update at a regular interval, and that's it. That's what polling is. So like, I am a server and there is a client. So the client repeatedly asks the server whether there is an update or not. And over here we have two ways in which we can question or ask server whether they have update or not. These are short polling and long polling. So let's discuss what short polling is. In short polling involves the client initiating request to the server at regular intervals. So if you have a look at this diagram, this is the client, this is a server, and this vertical line is a time. And you can see that after a certain interval, it pushes off a request. The client seeks request from the server, and there might be an update and there might be no update. So initially, at the start of the interval, it makes a request, and since the update has not happened, so you get empty response. Then after again at equal interval, you make a request, and since the update has already been happened, you get the response. And again after certain interval, you initiate a request, usually less than a minute. Some people make it a minute or two as well, depending upon the need. So this is what the short polling is, and the very best use case of short polling is implemented in the Hotstar website. So if you go to MySpace, okay, let's inspect this, open the network, and you open this request. Okay, so you see a QR code at the left, and what will happen is after certain interval, you will see some request happening automatically. Okay, so you see the first request happened here. And let me zoom this like this. So it was trying to see that if yeah, so the data was kind of empty, data was empty over here, but you see that this API request were trying to see whether a QR code login has happened or not, and after certain interval another call was made, the third call and fourth call and so on. So this is what a short polling is implemented on the Disney Hotstar website, which seeks at regular intervals whether the in the backend has anyone performed a QR code login or not. Okay, this is a very good example of short polling. And if I just log in using my QR code, so let me scan this. Okay, I have scanned this. Now I am opening my app. I have logged in. Okay, you can see that I automatically got logged in, and all the other requests that were happening is gone. So how exactly did this happen? So you can see, you have already seen that these request QR code login request happens automatically every time. Okay, so wherever the API responds back ki acha bhai, a login has happened, it will initiate some internal logic and land you to the login page or land you to the inside of your profile page. So this is a very good example of short polling technique, and now it is a time to implement a short polling technique on our side. So we will go back and close all the tabs. We will create a folder. I'll call this as short polling, and this is really very easy. All you have to do is make network calls inside a set interval at regular interval time, and you are all sorted. So this is going to be really very easy, very quick. So we have one client file and we have one server. Okay, we will open the server in the terminal and we do npm init. Good. I will create one file called server.js, and we will implement everything we have done in the REST APIs. Okay, so let me grab and paste it over here. This is import. So we will inside this I will add type as module. Save this. Okay, and we will install express, npm I express, and we will need cors and nodamon. Okay, so let me, oh, what happened, spelling was wrong. Okay, let us fix this. Nodamon. Okay, now we will do import cors from cors and app.use cors. Okay, this we have done. So what we will do is so we don't need some of the APIs which are delete. We don't need delete. We have update API, so we can use that. Okay, then I will remove this patch, or maybe I can remove this put API and use patch instead. Okay, so this is it. Then we will do go to server, add start script, nodamon server dot js. Okay, and we will do npm start. Okay, server is up and running. So we have initiated our node.js server, and on the client we will create one index.html file. I will boilerplate this down with this shorthand property, and we will write the title short polling. Tick. Then we will add a script, and I will create a function called as fetch data, which will perform a fetch API to HTTP localhost 3000 slash API slash problems. Okay, and dot then we can do async or await depending upon the need, but let's do this way. Dot then we get response, we do response.json, I do dot then, I get my data, tick, and we do console.log data, tick. This is simple. And I do write a set interval function over here where I call my fetch data function at an interval of 2 seconds. Okay, that's it. And I will initiate a go live server. Okay, now let's go back to the network. We can see that it is repeatedly fetching problems at an interval of 2 seconds. Okay, and it is getting some data. Fine. All I have to do is if there is a update in data, I will get the updated data. Okay, so I will open the Postman, and we will do a patch. Okay, and this is a new description. So I'll hit this API, and now I should get updated description, which is new description in the API calls. So after regular intervals, I am making requests in hope to get some data. People do this. What are the use cases of short polling? One we have already seen is that QR code login at Hotstar app. Some people do this in the messaging app as well, but it becomes very costly for someone to implement this, because for each flight you are making a TCP call, and this is a heavy call at the server. Okay, imagine 1000 2000 requests per user, and you have 1000 or 1 lakh users. Imagine the cost of the servers it would be. So this is not a very scalable problem, but for whose screen time is very less, for example the Hotstar app which we saw. Okay, it's not coming up. So Hotstar app which we saw over there, the screen time of login screen is very less, because no user will stay for 5-6 hours only on the login screen. Okay, they just quickly want to log in and move to home page. So for that cases, short polling is the best use case. Okay, but for chats, imagine someone chatting for 5-6 hours, and you're repeatedly asking user what is the new data, what is the new chat. That is not a good thing. So that is a very bad use case, and we have already I think implemented. Yeah, we will deal with WebSockets as well, and we will see how WebSockets plays a crucial role in implementing chat applications. But for now, we understood short polling. Let's move on to long polling. Now we talk about long polling. Long polling is very similar to short polling. The only difference is that instead of making network calls at regular intervals, we only make network calls whenever there is a certain update from the response. So we halt the apes. So whenever you make the first request, you initially block that request unless server responds back with the new data or the request times out. This is the major implementation of long polling. So if you see, there is no concept of intervals over here. The moment you initiate a request, okay, and let's suppose the data update takes a long time. Okay, so for example, this is a long time it takes, and then after a certain point you have the update, you send back the response, and again you initiate a new request, and you block that request until and unless it either expires, okay, or times out. Okay, then you initiate a new request, or if there is any data that needs to be sent back to the client, you get the response and you make another request. So we create blocking request to the server. So this is how long polling is made. We will implement long polling. This was the article which discusses short polling and long polling in detail. It is already in the description. You can check this out. And this is the article which talks about how to implement long polling in a Node.js application. So this is what we are going to do. It uses events to make sure that, so it is a pub/sum model, okay, that we are going to implement, and this is a really great example as well as to implement long polling. So we are going to initiate a new folder. So let's do that. So new folder called client and a new folder called server. We open it in the terminal. Let's do npm init, and we do npm I express events and nodemon, and obviously we have to implement cors as well. Let me grab this, okay, and we can clear this and open. This was short polling and this is long polling. So I create a new file, server.js. I paste it, and inside package.json we do type module, okay, and then we have to import events from events. Okay, so this is going to help us with the event, and I create a new request called as messages. You get a request and response, okay, and over here this would be our subscriber which is going to be created. So we have not initiated our event emitter, so const message event emitter equals to new events dot event emitter. So this is our event emitter instance, and over here I say whenever this particular event gets triggered, which is new message, the name could be anything, I wanna trigger this callback function, okay, and inside here we get some data like from and message, and I do response dot json from and message. Okay, this is really very simple, and we have this API which triggers the subscriber function. Okay, so we call this as new message, and we get request and response, and I extract. Okay, so I'm going to extract from and message from request.body, and message emitter, I'm going to emit the emitter event called as new message, okay, and I'm going to pass the data which is from and message. Okay, this is really very easy API, and we will do app.listen 3000 console.log long polling server started. Okay, and did we use cors? Okay, we have done the cors. We have already written port, so let's use this. All right, let's close this server, open this in integrated terminal, and we have to give the start script, start nodemon server.js. Tick. Then we do npm start and server has started. So what is happening is that, so whenever our client hits this API, we are not going to immediately send the response. We are going to block the response until and unless it times out or our subscriber function is triggered from some publisher. So to publish new events, we have a new API. Imagine this new message being triggered when someone sends a new message to you. Okay, this is kind of a small demonstration of a chat app. Okay, so this API gets called whenever someone triggers a new message, and this is the API which client seeks to receive new messages. Okay, so once this is done, so I have to create a new client, and to implement this we again do HTML and h1. I'll call this as long polling, and we have a script over here, and I create one function, make request. Okay, we call this function initially, let it be a async function, and I have try catch statements over here, and I try to hit our response. So const response equals to await fetch http localhost 3000 / messages const data equals to await response dot json, and we do console dot log new message data. Okay, and once we receive a response, I recursively call this function again, and if there is some error due to timeout or something, then again I console dot log the error and I make the request again. Okay, so this is client side implementation. We are going to go live with this one. Okay, and let us inspect it. Okay, so this is the long polling, and you can see that let me refresh. So this message call was made localhost / messages, and you can see that it is in pending state. No API response has been found. Okay, so what I will do is I will make a post request, okay, to the new message API, and this is Vedant and messages hey there. I make this request. You can see that this particular, the first response got the message Vedant hey there and so on, and it automatically created a new request. Now if I, okay, this request was not closed. Okay, this request was not closed. We have to fix this. So response.json message success. Let's restart the server, and I make this request. I got success. My first, let's restart. So this is the first message. I send the request. I come back. We have second response. Again, I send this message. This second one got resolved, and we got the third one. So this is long polling. So we are not making unnecessary API calls, which reduces cost on the server. But again, we are maintaining one TCP connection with the server always open, which means that you are always like n-1 with the TCP connections which you can make. Okay, so this is one extra cost, and since you are keeping this server alive, then this is also going to consume some bandwidth on the server. Okay, so this was long polling in nutshell. This is way better than short polling, and this is how we implement long polling. You can always come back and reference to this article. It is already in the description. So we have covered, where is that? So we have covered long polling, short polling. Now is the time to discuss WebSockets. So we'll discuss WebSockets in the next module. So we are very close to finishing off this entire video, and now after wrapping up polling techniques, we are on to the next module, which is WebSockets. So let me read it out, the definition. WebSocket API is an advanced technology that makes it possible to open a two-way interactive communication session between user, browser, and the server. So over here, you can see that we have a server and a client, and we initiate a HTTP connection, and we keep this HTTP connection open, and over that HTTP, we send bidirectional messages, which means that client can send messages to server and server can send messages to client, two-way communication. And we have the capability to close any side of the socket connection. So once that is done, the whole HTTP connection is disconnected. This is what a WebSocket is. The only major difference between WebSocket and polling techniques is that WebSockets establishes a single HTTP connection, and over that connection, two-way communication happen. And in polling technique, you create multiple HTTP connections. Okay, so there is no single HTTP connection where two-way communication happens. Okay, so we either send or receive data in a single HTTP request, and if we want to do it again, we create a new HTTP connection. So that is a major difference between WebSockets and polling techniques. And if the two-way communication is very frequent, so instead of using polling techniques, we can use WebSockets. WebSocket is fairly easy to incorporate than incorporating polling techniques if we consider cost of the servers and other stuffs, because here we establish only a single HTTP connection, so the server cost is less. Okay, where exactly it is used, like any place where you want real-time data to be present, for example stock exchange, Zerodha, right, or chat applications where you instantly get the message. So these are some of the places. So any requirement where there is real-time data is required, WebSocket is your guy for that. So this image was taken from Wikipedia. Links are already in description, and I think the definition was taken up from Mozilla. So you can read about WebSocket more on Mozilla website. Again, we have added the description, the link in the description. What we are going to do is we are going to implement a simple chat application. Okay, where I send message from one side, you get the message on the other side as well. That is it, we are going to implement. So for that, I am using this website as a reference, blackslate.io, and they have fairly explained WebSocket connection using Node.js and simple client, vanilla client. So this is what we are going to implement, and we are not going to use socket.io, but instead we are using WS package, fairly good package to use. So you can WS npm, you can search for ws npm. Okay, and you can see how this package behaves, but we are going to implement a basic version of WebSockets. So let's head over to our application. Let's create new folder called WebSocket. I create a server and a client. I close everything and we move into the server. We perform npm init, basic steps, and npm I. So npm I express and ws. Okay. Cool. And let's grab this code and put it in server.js. Okay. So let us see what this is doing. And in the start script, we also need nodemon. So npm I nodemon, and we give the start script as nodemon server.js, and we do npm run dev. Okay, sorry, it should be npm start. Okay, the server is up and running. Let us see what it has. We have Express. We imported WebSocket. We created instance of Express app, and we created a instead of WebSocket connection. So the WebSocket connection is listening on port 8080, and whenever a connection is established from a client, this function, this particular function. Okay, let me. How should I show this? Okay, this whole particular everything which is present in this callback function is going to be triggered as soon as a client gets connected. So it will log a client connected, and whenever a client emits a message like a message event, okay, you will receive some data, and we are logging this on the server. And for all the connected clients, I am going to broadcast this message. Okay, we are sending this message back to all the clients, and whenever the connection is closed, we receive client disconnected. Fairly very simple. And our Express app is running on port 3000. Very, very simple. Okay, now we have to do is we have to create index.html file, and I created this boilerplate. Okay, and I let me WebSocket, let me add this. Okay, and we create a div id equals to messages. Here we will receive all the messages, and in this, using this button, send button, id equals to send btn, we are going to send the messages. Okay, and I create one script tag. Okay, so first thing we do is const messages equals to document dot get element by id messages, and we have btn button like this. And on the client, yes, so on the client we don't really have to use ws package because the WebSocket global object is already present as a part of JavaScript. Okay, so I can do something like const socket equals to new WebSocket like this, and my WebSocket connection would be so this is, since it is a WebSocket, so it starts with ws and local host 8080. Okay, and yeah, since we required a WebSocket package for Node, so it's very evident that WebSocket is not present by default in Node, and this WebSocket is most likely coming from the browser API. Okay, and let me check if this is true. Yes, so we are correct. WebSocket API is part of the modern web browsers. Okay, so we don't really have to import any package on the client to use WebSockets. Now, once this is done on the socket instance, we add an event listener open. Okay, so whenever a connection is open, we can log something on the server. Okay, whenever a connection gets connected, so we console.log client connected to server, and socket dot add event listener message. Whenever a message event is being fired, we get the event in the callback, and we can console.log event.data. And once this is done, we can set the inner HTML as a div tag Obviously it has to be stringified. We got event dot data dot to string. Okay, so this way we get it. And what we have to do is we have to create a function send message. Okay, and we have to emit, so socket dot send the message. So we have not given an input to give the message, so let me add input type equals to text. Let's give this id as input. Okay, and once we have, I just have to say input dot value, and we have to call this function button dot add event listener click, and I called my send message function. So we have a basic server, basic client ready. We can hit go live, and we have the WebSocket. Let's check the logs. It says client connected to the server, and let's refresh. Okay, so if I do something like hey there, I send it. Yep, so you can see that this was the ws, this was the WebSocket connection. WS localhost 8080, a single uh, HTTP connection. It is open, and it is a bi-directional message. And you can see all the messages. So this was the message sent, and this was the message received. Okay, and we can to have this running. Okay, I am going to again open this over here, and let's open the network all. Okay, say how are you, and see instantly you get how are you over here as well. And we have, I think we have to reload. Let's reload and open this localhost so that we can see the messages. We get hey, so we received one hey data, and I send one hey data, and I reply how are you. You can see we got messages here also. So this is a really great example, and on the server you will see that message received. Okay, so client were connected and disconnected, and if I close this, you see our client disconnect message was received, and if I close this as well, a second message was initiated. So this is what web API is under the hood. It is really very easy. There is nothing more to understand on this. However, there are some concepts like creating rooms and so on, but that is something which we can discuss when we will talk about scaling backend applications. Okay, so there is horizontal scaling and vertical scaling, and imagine that there is a one node system having WebSocket connection. Some clients are connected. We have another Node.js connection scaled, so we spawn a new Node.js connection, and it has again WebSocket connection. Now the first WebSocket has to be in sync with the second one, and let's suppose the clients of these second one has to connect with first one. So it gets fairly complex over there, but we are going to talk about it later in other videos, not in this one because this is not the scope. So we have covered WebSockets. We are going to again push this. So we are going to push WebSocket, and then we are going to talk about webhooks. So this was all in WebSockets. I'll see you guys in webhooks. So we are in the last part of this particular series, which is webhooks. And if I say that you have already implemented webhooks in this video, will you believe me? So yes, we have already created webhooks before, and let me tell you what a webhook is. So webhook is an HTTP request triggered by an event in a source system and sent to the destination system, often with a payload of data. And webhooks are automated. In other words, they are automatically sent out when their event is fired in the source system. So what exactly is webhook? So to understand it, so I am referencing from this particular article from WebHook relay.com, and they have given a brilliant example. The link is already in description. You can check it out. So what happens over here is you are a user and you come to a platform where you want to buy pets, okay, for your house. So you place a request on the portal ki bhai I want a cat. Then let's suppose this particular platform uses Stripe as their payment gateway. So we have various payment gateways. You might have heard of Razorpay before, right? So Stripe is also one of the payment gateway. And what happens is once the request is placed to Stripe, the platform, the e-commerce platform doesn't wait for a response. Okay, so it doesn't wait for you to finish off the Stripe payment and then it returns back with response. This is not what the flow is. What happens is once you place a request, and for example you want to use via PhonePe, so a request then comes to the user's PhonePe, they accept the payment and they make the transaction. Then once this is done, you trigger a webhook on the e-commerce stating that this is the data of the payment, this was the user, this was the amount, this was the transaction ID, this was the order ID, and so on. And you send this data back, or you call an API on the store itself and you pass that data. And that is how asynchronously the database gets updated. You might have heard if you are an active trader or you invest in stocks. So when you apply for an IPO on Zerodha, for example, so once you initiate the request, okay, then your request comes, UPI mandate comes onto your PhonePe or Google Pay after 5-6 hours. So does Zerodha will really wait for you to complete the payment and then respond back कि अच्छा भाई इसने payment कर दी है? Does it happens? No, right? What Zerodha does is they when they make the request to Stripe or whosoever is your vendor is, they say that ki bhai this is my Zerodha platform, and on Zerodha platform there is this particular specific API endpoint. Okay, imagine Zerodha has created a backend on Express, so they have introduced a endpoint. For example, app.post/payment confirmation, and then you get request response. Anyone can globally around the world can call this request. Although there is certain level of authentication, verification, and whitelisting of vendors who can actually make request. For example, API has an endpoint of called api.stripe.com, and it uses it to call the webhook on the particular e-commerce. Then this particular e-commerce will whitelist api.stripe.com and they will pass on some secret keys, and they'll say ki bhai whenever you make an API call on our servers, use this secret key in the headers and I will whitelist your domain, so that there is some sort of authentication and no malicious user can hit this API. So webhooks are really very secured. They are behind secret keys and whitelisting. Coming back to the point is that whenever you initiate an IPO, okay, so you send to PhonePe ki bhai, Zerodha tells to PhonePe ki bhai this is the endpoint you have to call, this is the secret key, Whenever the payment is done by the user, you call this particular API back on my server, on the Zerodha server, and I will know keep this user has finished the payment. And the Zerodha also tells PhonePe or Google Pay ki bhai, while you are calling this webhook, make sure ki you pass on this order ID, you pass the user ID information, you give me the transaction ID, and so on. Whatever are the relevant details, you call back. Okay, so this is what webhook is. So webhook, in my opinion, is just a normal API which is triggered by some third-party vendor, okay, on your system. That is it. That is as simple as that. Okay, so this is just webhook is an alternate name for a API on your backend server, which is made in such a way that third-party vendors, in this case Stripe, PhonePe, Google Pay, can call whenever some event has happened. What that event is like doing a payment by a user. Okay, user can do payment immediately, or they would do after 3-4 hours or 3 to 5 days, whenever their will is. So this is where webhook comes into the play, and it is really very easy to implement. We have already implemented APIs, and if I want to show it, I can show, but doesn't really make sense. I create a GET request and a POST request, and I mimic everything from scratch. We have already created REST APIs before, so it's not required. Okay, and this is what webhook is. I hope you really found it interesting. And if you have came so far to the end of this video, please give this video a like. I have worked super hard for creating this first part of system design Yatra, and leave some good comments for me and share this with your friends. Make it viral in your college, in your office, in your community. Say that JS Cafe has brought out really well structured system design course for you, free of cost. Not everyone make this free courses and teach at this level. They charge primarily, but I decided to teach this for free. And please help me out in growing this channel. While I'm making this video, we are at 20.5k. So please hit the subscribe button, like this video, add comments, share this video in your community with friends in college, make it viral, and I'll bring more such videos for free for you on YouTube. So this was Vedant. Thanks for watching. I'll see you guys probably in the next season of System Design Yatra. Thanks.